now look at part 3 of the question. It asks, is star commutative? Is star associative? In order for us to answer this part of the question fully or well, one needs to know the commutative law and the associative law. Now, the commutative law states that the order in which we add or multiply doesn't really matter. In other words, A plus B give the same result as B plus A, and A multiplied by B give the same result as B multiplied by A. If we're going to test the commutative property, then we need at most two numbers. So we have 2 star 1 already. We have found that the answer is equal to 3. We must see if 1 star 2 gives the same result as 2 star 1. If that is the case, or if it holds, then the conclusion is that star is commutative. So let us now find the result for 1 star 2. Remember, we only need two numbers to prove the commutative law or the commutative property. And so we have now 1 asterisk 2 is equal to, again, we go back to what A star B is. A star B is equal to A plus B over A minus B. That one goes in. So if A star B is equal to A plus B divided by A minus B, then what is 1 star 2 equal to? Taking that in mind, 1 is will take on, or A will take on the value of 1, and B will take the value of 2. So that becomes 1 plus 2 over 1 minus 2. And that is equal to 3. 1 plus 2 is 3 over 1 minus 2. That's minus 1. And that is equal to minus 3. Now when we compare the result of 1 star 2 with that of 2 star 1, we realize that the values are not the same. 2 star 1 is equal to positive 3, and 1 star 2 is equal to negative 3. So to conclude, we make a statement that since 2 star 3 or 2 star 1, I beg your pardon, is not equal to 1 star 2, then star is not commutative. However, suppose we had worked out 1 star 2 that gives a value of, let's say, positive 3, then the conclusion would be, since 2 star 1 is equal to 1 star 2, then of course star would be commutative. So we have to look out for equality in the result for commutative property to take place or to hold. And since the two values are different, then the conclusion is that star is not commutative. The same thing we will do when we are testing for the associative property. Now, is star associative? We need 3 numbers to test the associative property. We know the value of 4 star 2 star 3. So if you look at the associative law, it says A times B in brackets times C on the outside must be equal to A on the outside times BC. We realize that 4 star 2 star 3 looks like the right hand side of the associative law property. So what we now need to do is to find or work out the left hand side of the property. So we now need to find what the value of 4 star 2 in brackets, of course, star 1 is equal to. Now remember, we worked out 4 star 2 star 1, where the 2 and the 1 are in a bracket. Now we are grouping 4 and 2. So remember, if the property holds or if the law holds, then the order in which we group the numbers should not matter. And so let us see what 4 star 2 really is. So 4 star 2 is equal to, always go back to what is given in terms of A star B, and that is equal to A plus B over A minus B. Remember, our A takes the value 4 and our B now takes the value of 2. So that becomes 4 plus 2 divided by 4 minus 2, and that is equal to 6. 4 plus 2 is 6 divided by 2, which is equal to 3. So we must now, therefore, we are now trying to find the value of 3 star 1. Why 3 star 1? Because 4 star 2, so let me just make a note for you to see exactly what I'm doing. 4 star 2 star 1, like this, is the same thing as 3, because 4 star 2 is 3, star the value of 1. Now again, this is equal to, we always go back, as long as we are applying the operation, we always go back to what is given. A takes the value of 3 and B takes the value of 1. And so this now becomes 3 plus 1 divided by 3 minus 1, and that is equal to 4 divided by 2, which is equal to 2. And then we compare the result. Are the results equal? The answer is no. 4 star 2 in brackets, so we make a note, just like we did before, since 4 star 2 in bracket star 1 is not the same, say that is not equal to 4 star, and we have our 2 star 1 in bracket. Since they are not the same in terms of value, numerical value, so since they are not equal, then star is not associative. So remember, for the associative property to take place, we need equality in our final results. And remember, if the results are not the same, then we draw the conclusion that the binary operation doesn't hold for associative law. However, if both results are the same, then we would say that star is true, or it holds for the associative property, or it is associative. And we need 3 numbers for testing of associative property and 2 numbers to test the commutative property.